This is Megan Longoria bringing you week 10 of Workout Wednesday Power BI edition. This week we're looking at the Violin plot custom visual. Custom visuals allow us to extend the visualizations that are available in Power BI. Some are made by Microsoft, but many are made by third parties. We can download them into Power BI Desktop or the Power BI service for use in a report. So this week, we're going to use the Violin plot custom visual to create this visual of daily average temperatures in Denver, Colorado for the year 2020. We have a few requirements. This week, we have a Power BI or PBIX file all ready for you. If you click the link, you can download that. It'll take you to a OneDrive location and click download. And when the file opens, you should see two tables in the fields pane on the right, date and temperature, and a blank report page. I've included some helpful links on the second page for you to find the source data if you're interested, as well as learn how to import custom visuals and get more information on the Violin plot custom visual. For most people, you should be able to import custom visuals from right here within Power BI Desktop. So I'm going to go to that ellipsis menu and get more visuals. And then the app source window will pop up and I can search for Violin plot. If I click on it, I can get more information, who made it, what version we're on, when this version was last released, see some examples. And I'm going to go ahead and click add, but first notice the white check mark and the blue star. That means this is a certified custom visual. It means this has been reviewed by Microsoft to meet certain criteria, both for performance and security. So once I click add, I'll see the visual was successfully imported into the report. My Power BI tenant, since I'm signed in from my work account, allows the use of custom visuals. There is a tenant-wide setting that your Power BI admin might set to say no one can publish custom visuals to the tenant. If you're signed in, you might not get the same option. That's okay. You can download the .pbiviz file, that's the extension for a custom visual, from Bitbucket, from the author of this custom visual, and then you can just upload it. So if you have to do that, you'll choose import a visual from file, and then you find your PBIviz file that you just downloaded. You'll know it worked because you'll see it here in the section below the default visuals. So I'm going to add the Violin plot to my page, and I'm going to go ahead and make it take up pretty much the whole page. And we want to show average temperature by month, and I know that there's one row per date, so I can use that for my sampling. And so we've got the start of our Violin plot already. But I'm going to change a couple of settings. First, the box plot used here is the default and what you'll most often see, but we're going to use the barcode or strip plot. Then we need to check our Violin options. So I'm going to change my sampling resolution to high, and I'm going to leave the kernel on the default. And we can see already we've got a white line shown, and that's part of that barcode plot. Each of these dark lines is an individual value, and the white line represents the median. We have control over which reference lines we see, and we want to show the first and third quartiles as well as the median line. So those are now turned on. And since I'm here, I'm going to go ahead and fix my text size and make it at least 12 for both the X and Y axis. And then format my tooltip. Oh, default tooltip details. So I want to make sure, by default, we see it's got 2 places after the decimal. That is more precise than we really care to get, so we're going to make sure that is 0. And that way when we hover, we will get integers. Next, I'm going to change my chart title to be a little more descriptive and call it 2020 Daily Average Temperatures in Denver, Colorado. And I want to make sure my title is nice and big and easy to read. Same thing with my legend. And then I want to fix my colors. So the requirement for the colors is that we have good color contrast. We want a color contrast ratio of at least 3:1 between the background, this lighter blue area, and the individual data points, these dark horizontal lines, as well as the background and the reference lines, so our median and our quartiles. And then as well as the data points and the quartiles and median lines. So we're measuring the difference between 3 different colors. We also want to make sure the outline, the darker part of the outline for the violin plot, has a color contrast ratio of 3:1 from the white background. You can choose any colors you want. You just need to measure and make sure we have good contrast. So I'm going to go through and fix my text colors first. I usually choose a dark gray or off black for titles and legends. And axis labels. And then I'm going to fix my data colors for the violin plot. And I'm going to choose gray. And make it 50% transparent. And then my bar color for the individual data points And I'm going to change my color for my individual data points to an off black, so it shows up against that gray background. And I'll leave the stroke width at 2. Next, I need to change the line color for my quartiles. And I pre-measured some of these, but I'll measure them again when I'm done to be sure. So let's do a blue color. And I'm going to make it just slightly wider and solid so that it shows up better. The dashed lines can be a little difficult to see sometimes. And I want to go ahead and make my first and third quartile lines the same. So I have 2 blue lines within each violin. But I'm going to do something a little different for my median. And I'm going to make the median a different color here. And I went ahead and made that stroke width 3 as well, so that if there are individual data points near it or covering it, we're able to still see our reference lines. So I'm going to check my colors now. I use a tool called Color Contrast Analyzer. So the first thing I want to do is go to my violin options, actually data colors, and get this color. And this is a little desktop tool that's free to download. And I can either try to sample it off the line over here, or I can just go hover over the box with the color in it and get my gray color. And I can see that the contrast from the white background to the darker gray outline is 3:1, so I'm good there. And then I can sample the individual value and the lighter gray color and see my individual lines have good color contrast. And I can check my quartile lines are above 3:1 from the gray background. My median line is above 3:1 from the gray background. And then I'm going to check, since my reference lines can be next to an individual value, that I have okay color contrast between those as well. So now we have our violin plot. We have a legend at the top that tells us that the gray violin shape represents average temperature readings in Fahrenheit. The dark black lines are individual temperature values. The first and third quartiles are the blue line, and the median is represented by that kind of purple magenta line. And you'll notice as I hover over data points, I'm getting a nice tooltip that has lots of information. So our last requirement was to identify which months had the highest and lowest standard deviation. What's nice about the violin plot is that we get to see both the frequency of values. When the violin is wider, that means there are more values in this area, as well as the distribution of values. What's the range from the highest to lowest, and where are these values located? Are they clumped together, or are they really spread out? So I could just look at these violin strip plots and see that this one is the longest and has some really spread out values. And July is the shortest and has lots of values together. But I can also confirm by using the tooltip, and I can see that the standard deviation on July is 4. So if I check a couple other small ones, August is 5, January is 6, so we should be in good shape to identify July as having the smallest standard deviation. And since this violin plot for October is the longest, we'll see the standard deviation is 15. And if I check a few more, we got 10 for December, 12 for April, 11 for February. So we've confirmed that October has the highest standard deviation. So I hope you enjoyed using a custom visual this week. And if you weren't familiar with violin plots, learning a little bit more about them and the variations of the chart that can be represented on top of the kernel density plot.